Bots have revolutionized the workflows. Most of the companies and high-powered professionals are utilizing it in their day-to-day work. In this video, we are going to build our own personal bot, and we don't have to pay anybody for running that bot. Isn't it fantastic? Just follow along with the video and you are going to learn a lot of things in the process. If you are a software developer, it will be a very important project. You can apply various learning you must have done and even find new ideas while building this bot. So let's begin. Let's talk about the requirements. For this video, you will just need a Raspberry Pi, which I have got here, Raspberry Pi 3B. This is the model. There are many models available in the market and they vary in prices based on the configuration they have. This is quite inexpensive model. It has 1 GB of RAM and a decent processor, ARM based. You will have to purchase a SD card, micro SD card, which is of this size. You can purchase of size 16 GB plus, that will be good. This Raspberry Pi is inside a cover which I bought so that it looks good and stay protected. If I open it up, you will find there are various parts to this Raspberry Pi. Okay. So essentially there is a complete motherboard where you have processor, RAM and all the parts required for a functional computer is there. It's amazing to have such a small package where you can compute and do all the things you would normally do with the computer. Although this comes with certain configuration limitation, for example, RAM is limited, otherwise the prices go very high. The processor is not so great, but this gets the job done, and for a server which is running at your home, this is a very decent option. Now let me go back and close this. Essentially, Raspberry Pi is used in various projects. It has GPIO where you can create your own IoTs and you can program to run various circuits. We will talk about such use cases in future. For this video, I just need Raspberry Pi to act as a server at your home, and you can run N8N on that Raspberry Pi, and using that you can create your own bot for various automation that you might want. One of the use case could be to automate your social media content, which I heavily rely on. My Instagram posts are generated by this N8N workflow which I have created for myself. My Instagram post on one of the profile which I have, which is Nerdy Camera, I have automated the posts which go on the Instagram in the morning and the evening through this workflow only. So I hope you will find many such use cases for yourself. Second thing, you would need a reader which you can purchase from Amazon or other online shop, where you can attach your micro SD card, and this will go into the SD card slot which is available on your MacBook or computer, or you can have USB device as well which will have the slot for SD card. Some USB dongle will also have micro SD slot to directly read. So this will be very convenient. If you can buy such a dongle, then you will not need an adapter for SD card. Optionally, you can have a LAN wire which you will connect the Raspberry Pi to your Wi-Fi or router. I am going to use Wi-Fi only in this case. I won't be connecting it to the router directly. You will also need USB type B wire and a wall charger so that you can power the Raspberry Pi. This is the hardware requirement. This is quite inexpensive. You can get it for less than $50, or in India less than 5,000 rupees, and you will have it for the lifetime. You can do so many experiments on the Raspberry Pi. Plus, you are not going to pay for any of these services. Otherwise, service like this could cost you for month only 1,000 rupees. So this is going to be very good investment. One more thing, this model 3B has only 1 GB of RAM, and generally you would want to have more RAM. I'll show you the technique where you can just use 1 GB of RAM and use the swap to increase the performance of your program. Otherwise, you can invest more and buy a 4 GB or 8 GB version of this Raspberry Pi. So great, this was the first requirement. Next requirement is N8N Library, which is open sourced. You can get it from GitHub and you can install it via npm or Docker. We are going to utilize Docker for this video. N8N gives a visual way of creating this workflow, and it becomes very easy for us to create and manage the workflows. We'll see further in this video. And the third requirement would be few Linux commands. You don't have to learn it. You can follow along as I go, and in the process I will also explain what they are doing. So this will be a very good project for anybody who wants to experience firsthand how a system or backend developer works under the hood. Now let's first prepare our Raspberry Pi operating system. In order to run the Raspberry Pi, I would want the Raspberry Pi to run an operating system which does not consume a lot of RAM. So for our use case, Raspberry Pi Lite OS would be the perfect match. For this, you will have to download Raspberry Pi Imager, which is free to download. You can download for the operating system where you are working. I'm going to download it for the MacBook. Once you download it, then you will have to install it for your system. And after you do the installation, you will get this Pi Imager library. Okay. Now you'll have to use your micro SD card and put it in the micro SD card slot of your USB dongle. Now you can also use this adapter if you don't have this dongle. Select the Raspberry Pi model you have. I have 3. Then select the operating system. I'll go and select Raspberry Pi other OS because I don't want the desktop version. I just need to run my N8N library. For that, I would just need a server. So I don't need any UI, any extra things, because that will consume RAM, which I don't have. Here I'm going to install Raspberry Pi OS Lite 64-bit version. This will be smaller in size, plus its RAM requirement will be much less. So RAM which is left will be utilized by the N8N program. Now select your external media and then install it. Now enter the host name. You can choose the name of your choice. I'll say that it is my Pi. Now select your city, time zone, and your keyboard layout. Username, I'll call it Pi user. Now you go ahead and select the password of your choice. I'm going to choose 1, 2, 3, 4, 5, 6 for the purpose of this video. 1, 2, 3, 4, 5, 6. Now next. Now you must put the network ID, Wi-Fi ID here. Now don't make a mistake, otherwise you'll have to do the same process of formatting the card and then reinstalling the operating system, because I don't want to connect this Raspberry Pi to any desktop monitor or TV to do the processing. I just want to control this Raspberry Pi directly through my laptop. So I have to make sure that it connects to the Wi-Fi when I put my operating system there. So my SSID here, and it only support 2.4 gigahertz bandwidth. So make sure you connect with the 2.4 gigahertz bandwidth only. Now password of my Wi-Fi. Okay. Then here it is saying that customize the SSH. SSH is important because you want to control this device using your laptop. So you will connect it by the SSH. So you have to enable the SSH and here use the password authentication. Okay. Password is the password that you have set in the last step. Now, Raspberry Pi Connect, no, this is a paid service. I don't want this. Write the image, yes. Now it will ask to erase and write. Yes, do it. Read write speed of micro SD card is very slow. So don't expect the speed to be like an SSD. Be patient. Second, you can apply this concept that you are going to learn here on hosting N8N on any laptop or even in the cloud infrastructure like Amazon, AWS, Google GCP, Azure, etc. Now our write is complete. Let's finish. And now we can take our SD card and then we'll have to put it in the Raspberry Pi. This is very fragile, so be very cautious. After that, you'll have to power up. For that, you will have to use USB type B, micro USB in the power socket. And then you'll have to power up. Once you power up, you'll see the lights are blinking and this green light will turn red and green, and this will be an indicator that the processing of your operating system has started. We'll have to wait for a few seconds and then we'll go and connect with this through SSH. To connect to this device by SSH, you'll have to open your terminal. You can use a terminal program of your choice. I'm going to use the default terminal program of Mac OS. Here we have to write SSH and the IP address of this Raspberry Pi. Now when the Raspberry Pi ran, it connected with the Wi-Fi and an IP address was provided to this. But we don't know the IP address. So how can we connect to this device? Very interesting. So either we can connect Raspberry Pi to an external monitor using HDMI. You can connect to it to your TV as well. And then you will have to connect a keyboard and then you can type some command and you will find the IP address. But that is not what we want to do. We'll do a very interesting thing. We'll write SSH username which was created in this Linux distribution. This is a Linux distribution. Username, do you recall the username? It was pi user at the rate, the device name my pi dot local. Asking for the password 1 2 3 4 5 6 that you had said earlier. Now it has connected. Let's talk a bit about .local. .local is a domain name, top level domain name but it is reserved only for local area network. You cannot use it for your website or anything else like that. This is a part of multicast DNS where whichever devices are connected on the local area network responds to the call to this DNS. For example, if you ask my laptop.local, essentially you are broadcasting this message that whichever laptop has the name my laptop must respond with their IP address. So this way you just have to know the name of the device, and that device is going to reveal itself with its IP address. This is a very interesting implementation. This is how all the devices, if you have multiple Apple devices, they are able to discover and find each other very easily because of this special DNS. Now let's come back and see what's there in our system. So once you have been connected with the SSH, you can write a command htop. Htop is a very simple program. It gives you all the processes which are running on your device and the information about the CPU, memory, and the swap. Now you have 4 CPU cores and only 1 GB of RAM. 1 GB of RAM might not be enough. So there is a way to increase the capacity of RAM by using swap. Swap essentially utilizes your micro SD card for storing temporary files, and in that way it increases your RAM capacity. But again, the speed will not be of that of a RAM. Plus, it can degrade your SD card if it is used rapidly. We are going to use swap here because we don't have enough RAM. You might have a device which have more RAM, then you can skip this part. But I would need to have a swap memory. And if the SD card deteriorates over time, I can buy a new SD card. This is fairly inexpensive. So let's go and set the swap memory. Now I'll open up one more terminal and rearrange the windows. I can open more than one instances of SSH. In one place, I'm going to monitor my RAM and the processes, and the other I'm going to run various commands. So let me write SSH again. Username was pi user @my pi dot local 1 2 3 4 5 6. For the swap, we'll have to run Linux commands. Don't worry, don't have to remember it. I'm going to provide it in the comments below, also in the link for the GitHub. So both places you will find this code. I'm going to copy and paste from my notes and will explain what I'm going to do. First, I have to allocate the swap size. Swap is a memory which helps your RAM to temporarily store files when it is filled. So here we are going to allocate 1 GB of extra space. It is asking for password because I am writing this command using sudo. My password is 1 2 3 4 5 6. Sudo is super doer. Okay. Now I'll have to write certain more command. Let me list down the swap file. Yes, permission is for the root 1 GB and the date etc. is printed. Give me, let's give the permission to read this file. Yes, chmod. Then again, let's see the permission. Yes, all the permission are now there. Let me make the swap. Okay, so now it is setting up the swap, and then let me apply it. Swapon Then let me see the swap that has been created. Yes. Now there are two swaps. First was created by the operating system when it got installed. Second is the swap file which I am creating of 1 GB size, which is in the form of a file. Then let's create a permanent swap configuration, because once we restart it, we want the swap to be remounted again. Yes. Then let's change the swappiness. First, let's see the swappiness 60. It means swap is going to be utilized more often whenever there is some pressure on the RAM. We want the swap to be utilized in the last resort. For that, we'll have to reduce the swappiness, and hence we will reduce the swappiness to 10. Now let me save the swappiness into system, and then finally let's print. All this command will be available on the comment as well as on GitHub repository. You can copy and paste, and you can go in more detail. After changing the swap, let's see the htop. Here you see the swap is now 1.88 GB. 1 GB you have added, 880 was created by the system itself. So now you have 1 GB of RAM and 1 GB of swap. Effectively, you have 2 GB of RAM scope for your program. Now let's update the operating system. Why you want to do this? Because you will have the latest features and more stable system you have. You can skip this part as well, but I will highly recommend that you go on with this update. So first let's write sudo apt update. It will take some time for the update to take place, so be patient. The working on operating system and the backend side requires you to be patient, and this is where your patience is going to be tested. Yes, now I have to update. Let me fully update all the files. Sudo apt full upgrade -y. Now it will take further more time. Now our installation is finally complete. Let's remove some of the unused programs. After that, we'll have to reboot our Raspberry Pi so that the update to be loaded. And once you type the reboot program, your device will restart, and you'll have to wait for 30 seconds to 1 minute for the program to load again, and then you can again get the access to the SSH. Let me clear both the screen. Let's try. Yes, it is back on. And after the password, yes. Now you're back on. And here again, let's do this. Yes. Now we have updated our operating system to the latest version. We have set the SOP. Now we'll have to install the N8N. And for installing N8N, you have two ways. One by the npm and second by the Docker. npm will take a lot of time to build, so I want to use Docker. And official Docker image is available. Let me show you. Here the instructions are there. I'm going to use the instruction which is very effective to run the N8N on the Raspberry Pi. So follow along with my recommendation. First of all, you'll have to install Docker Compose. Docker Compose helps you run the program through the configuration Docker file. So for that, you'll have to install the Docker Compose by running the curl to get the docker.sh file, which has the script to install Docker. Okay. And then execute that sh file, sudo sh, the sh file. Again, provide the password. Now it will also take some time for Docker to install. You can keep a check on the memory. So far we haven't crossed 1 GB mark, so my swap is not utilized. It may be used when there is memory pressure. I am creating this buffer of swap for the N8N program. When it runs, it might require more memory and my swap would be utilized then. Yes, our Docker installation is complete. Let me check. Docker version 29.5.3. Now after Docker, let's check Docker and the Compose version as well. Docker Compose version 5.1.4. After that, let's install N8N. For that, we'll have to create directory called N8N Compose. Okay. Then get into that directory, cd N8N Compose. We'll have to create an environment file. And for the environment file, you have to write nano.env. Now, the environment file is the file where configuration for N8N is defined. For example, what will be the password, what will be the port number, and all those things. So when you write nano.env, it opens the nano editor, and here we are going to provide this content. Just copy paste as I am doing here. This I have already created for you. So the host is the local host. We are running in the local server. Protocol is HTTP, port number 5678, and the webhook URL is HTTP localhost. Security part, this is something which I found was useful when you are exposing this service to the outside world. You have to set the time zone. So time zone for me is Asia and Kolkata because I am in India. You select based on the country and the time zone where you live. Now you have to do some more configuration to make your system stable. For example, public API I am disabling it, diagnostic I am disabling it, notification I don't need, template I don't need, and setting all the external URLs to empty. And when the execution complete, it will save the data and the maximum age to live. So this configuration I found was important when you create your workflows. So feel free to add more configuration as you like. Then Control X and save it. So you have created the environment file. Let's now create a directory called mkdir local files, where it is going to save local files. And now we have to create the compose file, nano compose.yml. Here I am going to write the recipe for creating this Docker container which has N8N instance. So here first I'm going to create a service. This is a YML file, and first there is a service, I'm calling it N8N, and it will take the image from the official N8N Docker image, and it will always restart whenever there is a crash. It will take the environment from the .env file. It will map the port, local port, so that we can access it from other computers on the same network, and it will have volume, which is for saving the data, and local files. Finally, I will mount the volume. So after this configuration, I'll save it. Now, I have created the recipe for creating N8N using Docker Compose. Let me execute the Docker command. So I'll write sudo docker compose up -d so that it will create and download all the instances, and in the background it will run it by -d. It is pulling the instances for the N8N Docker image. It will also take some time. Now we have Docker created and all the instances are now running. Let's check if we have the service running at the port that we decided. nc -v localhost port 5678. Command will be nc -v localhost. Yes, connection to the localhost is successful. Now let's check the IP address of my Raspberry Pi. Host name -i. IP address is 192.168.1.44, and on my device I'm going to open the IP address, supply the port 5678. Yes, so now your N8N program, which is running on the Raspberry Pi, can be accessed through my laptop by supplying the IP address of Raspberry Pi and the port number on which we ran the N8N. And here on the first access we'll have to create a user, and from the subsequent access you can use this username and password. Let me write my email ali@afteracademy.com. First name Janisha, last name Ali, password let me write 123456. Okay. Now it is asking me to have more meaningful password. Okay. Let me use a strong password. So this opens the N8N workflow window. There you have to create your workflows, which we'll talk about, and hence you'll be able to create your own bot, your own AI driven workflows, which could be very meaningful for you. In N8N, workflow is like defining the steps that you'd want your program to take. So each unit of execution is node. So let's say we build a workflow, and let's create the first step. First step generally would want to have some trigger. Trigger could be a time of the day. Let's say that for our Instagram post for which we are trying to create a workflow or a bot, we will have a trigger at let's say 10 a.m. and which will then go and fetch the information for us and finally create an Instagram post using the Gemini API, and will provide us that post either through Discord or email of your choice. Now here we are going to use Discord because that is where I want all my information by this chatbot to come, and we are going to utilize Gemini's free API for this process. First step would be to add a trigger, and trigger will be on a schedule. Here you will find that the trigger should happen at 10 a.m. Okay, so let's test this trigger. It is executed. So this is the node. First node is the scheduled trigger node. At 10 a.m. each day, this trigger will be called. Now we'll have to create the workflow which will happen after this trigger. So after, let's say, this trigger, what do I want? I want to fetch some data, and for that I would want to have a list of URLs. For example, afteracademy.com has many blogs, and each day I post a summary of that blog on Instagram. So I'll have a list of blogs from which I am going to create Instagram post. For that, I have a very useful way of creating that list, that is through data tables. The data table is um, a form of storing the data in a row and column format, which is essentially SQLite database. Let me create a data table. Call it LinkedIn post. If there is some API from, let's say, LinkedIn, we can utilize that. If there is some API, if we are posting on Instagram, we can use that in the workflow. LinkedIn does not provide the API for personal use, so that's why we are going to have the post delivered to us and then we'll post it on LinkedIn manually. For Instagram, what I have done is utilize the API of the Instagram, and it automatically posts on my behalf. So there I have no intervention, and that is quite helpful. From scratch, let's create. So now it has created few tables, ID, created and updated at. Let's add few more fields, fields like link, the URL from where the data has to be fetched, or my blog URL, which will be of string. The data could be of type string, number, boolean, or date time. So this is going to be a string. One more row, I want to track if that particular content has been updated or post has been created for it or not. For that, let me create one column. I'll call it used, and it will be a boolean. And one more column, I will store the created post in that table so that I can reference later as well, which will be of type string. So I've created a schema where I have ID, link, a boolean flag used, the post, uh, created at and updated at. Let me add data. I can have a CSV file as well. As we saw earlier, we could import the data from CSV file as well, but this is for the demonstration. Let me open the After Academy and open some of the blogs. For example, this blog. This is the link. I want this to have a link. Okay, used is false, post is null, created at. Okay, one more URL from the publication. Let me also get one more URL. Another row. You can add as much data you want as you like. Now I have my list of links from which I want to create the Instagram post, and I have created a table and saved my data into the table. Let's go back to the workflow. This is the workflow, and this is our trigger. After the trigger, what do I want? First, I want to fetch all the data which is stored in the table. Then for this case, I'll have to fetch the row from the table, data table. In the data table, I want to have get rows. In the get rows, I would want to supply the list, Instagram post. Any condition? Yes. Condition is used should be false. It is false. Whenever I use some entry, I don't want to use it again. And it should return all. Let me execute it. So I have two entries which I have created in the table now available to me after this query. So I have added a node which will get all the data which has not been used. After that, I would want to get the first content, the top content, by sorting the whichever content is created the earliest would be provided. So here I have to create the top content, and for that I will have to write a JavaScript node, a code in JavaScript. Here, first of all, I have to get all the items. Okay, so the code is here. Input is the information from the previous node. Now I'm getting all the rows which has been provided from the previous node and save it into the items variable. And then I want to return if there is any item, that is items.length. If length is there, if there is any entry, then I am going to provide a list of item 0, first entry. Else I will be providing an empty list. Let me execute this step. Yes, I got the first item. So I read all the items from the input, supplied it to the variable items. If there is any item there, I am getting the first item from the list, else return the 0 to the next node. This is the code node. After that, I have the URL. I will have to get the HTML. For that, I will have to make the HTML request. So here, I'll open up the HTTP request. HTTP request. I'll make a call HTTP, and here I will have to give this URL. This URL has to be dynamic. That is what was selected from the previous selection, and the data of the previous selection is on this side, input. Here I need to supply the link. I can just drag it here. So I'm making a get request, HTTP get request to this URL, and after I get this data, I'll have the HTML, the entire HTML page for my blog. Now, what I want to do, I want to extract the text from that HTML file. And for that, I want only the blog part so that I can process it well via the LLM so that they can summarize it. For that, I will have to identify first how to get that particular blog element. For example, if you fetch this page, you will get all the information, the header, the footer, and everything else. I just want this text where the content lies. So we have to identify the container, a div which has this data. If I inspect it, I see that if I choose a class, this if I so here if I select this class, then I would find this div. So here what I'm going to do, I'm going to add an HTML, work with HTML, extract HTML content, and here now I want to extract that particular div value, and after the extraction I want that the extracted value should be supplied to a key which is called article. So whatever the text I'm going to get, I'll supply it to an article variable. And CSS selector, as I said, I'm going to write this CSS, this one, dot, and the class name, and this will return text. Do I want the text form? I have HTML. I want to get the HTML content because this is formatted as an HTML content, and this will be better if we're going to have formatting restored within that extraction. If I execute it, now see, I have my article only from that page. Now after this article, I would want to pass this HTML to the LLM. For that, I'm going to use the free API of Gemini. For that, you can get the Gemini API. You'll have to log in with your account, and then you will come to this Google AI Studio. There you create an API key. Let me call it demo Gemini API key. Create a key. Now I have got the API key. I'll use this API key and then I'll use it in my project. In the project, I will have to first use an AI. There, I will have to use the Google Gemini node. In the Gemini node, I want to do what? Message a model. Okay. First, you have to set the credential, the API key that you have created. Create an API key, yes, and then save it. Now, your API key is provided. Then it will be a text resource, and this will be a messenger model, and select one of the model, free model that you want. Let me select the Flash latest variant. Flash is the lightweight version of the Gemini, and you can use it decently for your free work. If limit is reached, your execution will stop. So make sure you keep a tab that you are not over utilizing this free APIs. Now prompt. You can write your prompt, but you can generate your prompt as well, which I'm going to do. I'm going to use Claude, and I'm going to ask Claude to give me a prompt. Give me a prompt to create a LinkedIn post from HTML text. Make it engaging and keep hashtags. You can improvise on this as you deem fit. This is for the demonstration purpose. Now it says, you are a LinkedIn content writer. You will give the HTML. I will give you the HTML text, convert it into all those things. Just copy this prompt and paste the prompt here. Here is the HTML text. So here replace it with the article that you have. And I would also want to supply the link. Add the link. And also add the link of the article. Okay. The HTTP request. I have the link in the other nodes. The node get rows. This has a link. I'll supply the link here. Right. So I created a prompt where I gave the instruction to create a LinkedIn post using the HTML text, and also said that use the link in the post as well. Now let's execute this step. Now you see you have got the post generated through the LLM Gemini, and it says building a Node.js backend architecture and give all the information, and it has supplied the link as well. Great. So now we have got our own bot which performs actions based on the condition we have provided. Now let's, after the content generation, we want to update the rows so that we can have the new rows, new content created for the next run. And here, let me table operation, data table, and here I want to update the row. And for update, what I will do, from the list LinkedIn post, condition, match all the condition, and condition is what? ID. ID is equals to, what was the ID? The ID for which we did the processing, which was in the row in the JavaScript, we got the ID, and ID equals to this code in JavaScript. Now, what do I want to do in the update? This is used, so I'm going to update that it has been used, and the value of post which was generated in the previous step. By dragging and dropping, those values are assigned from the variables. Let me execute it. Okay, it says it is saved. Now we'll check it in the data table. Now it is already saved. Let's check our data tables. The LinkedIn post first was updated. I've got the post and it has been updated. Next time the second link will be used for creating this post. Great. Let's go back. So we were able to create a trigger and then select one link from which the post has to be created. We extracted the HTML, sent that data to the Gemini, and from there we created the post and then finally updated the data in our table. And the last step, we can send this wherever we want. We can make an API call, we can send it to Discord or email. Let me send it to Discord. And Discord, I want to send a message. send a message. For the Discord, the best way is to use the webhook. And in the webhook, you can set up a credential. For example, I have a webhook, https discord.com. This is the webhook you can create on the Discord, and then copy that webhook and paste here, and then save it. And then operation is send a message. You can send a message of this post which is created by this model. Okay. And now you have your workflow ready, where each morning from the provided URL, your workflow or your AI bot will generate a LinkedIn post, send it to you on the Discord, and you can just copy paste that Discord post in the LinkedIn. You can paste it, and finally you will have your own automation created. Finally, you must save and publish it. This is just scratching the surface. You can utilize this for creating any type of automation, and this is very powerful. I have utilized it to automate my Instagram as well, which we will talk about in some other video. So do subscribe to our channel if you want to know more about automation of the Instagram. Thank you for watching this video. I hope you must have learned something meaningful. To subscribe to our channel and motivate us to create more such learning videos.